Hi, my name is Thomas Burg, and I am working on identifying musical instruments using machine learning. In particular, I am using a neural network, which is a series of interconnected nodes used by computers to loosely model the functionality of neurons in the brain. Neural networks are being used everywhere, from object recognition in images to cancer detection in hospitals. This also includes instrument recognition. Neural networks have been used in the past for instrument recognition, using convolutional neural networks and passing in extracted features from the audio. In addition, polyphonic samples, audio with multiple instruments playing at once, have also been used in some models. This project differs from these in that we are using a recurrent neural network, and instead of passing in features from the audio, we pass the audio directly into the model. We're able to do this since recurrent neural networks work well with sequential data, and audio is recorded as many smaller samples of audio, played one after the other like a video. Our data is coming from the RWC music database, particularly one containing 50 different instruments, playing every note in the full range of each instrument, generally in 3 variations. From there, we split the scales into 1-second chunks based on the silence between the notes, and downsample that from 44,000 Hz to 16,000 Hz. From here, we selected 5 instruments to use training the model: piano, violin, cello, trumpet, and clarinet. The model consisted of more than 70,000 trainable parameters. The model used a bidirectional LSTM, standing for long, short-term memory, that does well with sequential data, as discussed before. The model was trained for around 200 epochs, lasting about 1 hour. In the end, we were able to create a model training on 5 instruments with an accuracy of 90% and an F1 score of 0.89. Reading the confusion matrix shown here, we can see the results of the test data on the model, showing the true label on the vertical axis and the predicted label on the horizontal axis. It can be seen that the majority of the confusion happened with the trumpet and clarinet, whereas piano, violin, and cello all trained relatively well. Moving forward, there is much work to be done. This model can fairly easily be scaled up to include more instruments, and future work will include increasing this model to 10 or even 15 instruments, paired with longer training times. In addition, to be better applicable, polyphonic samples, those containing multiple instruments, should be worked on, since most applications for instrument identification in music would include more than one instrument. Thank you.